All right, in this lab, we're going to add in some software development components and then put a load on a server and monitor it as it's under load. So give us some semblance of real world watching and monitoring of a SUSE Linux enterprise machine. To begin with, though, we need to add in a software repository to do this. And we're going to do this. We're just going to add this in, and we're going to click the add button, and we're going to do DVD, and it's on I think it's on SR1 that we want. It is. And then we're just going to grab the development tools module, and we're going to add the legacies module as well. We're just going to use a couple of different tools here, and we'll just go ahead and add that. We're just adding our repository in. All right, so we've got the new repositories there. And now we're going to add in the actual tools. We've got the modules added. So it's a software single. And we're going to go in and we're going to add base development under patterns, just our base development in order to get that running. Let's see, base development is right down here under development. We're just going to add that in, and we just click accept, and it will go ahead and add in the stuff we need and push that across for us. Okay, so we get this software added, and then we're going to install a couple of things. We're going to install kernel source. We're going to add a couple of other tools, and then we're going to have it start compiling a kernel. And while it's compiling the kernel, we'll take a look at the load numbers with top and kind of watch how that is affected. We'll talk about that impact, and it should give us a good idea of what this is supposed to look like. So we've got that installed. We're going to clear this, and let's just do a top. We're just going to leave this running. We'll just put this over in the corner like that. And then we're going to open a new window here. We'll just expand it out just a little bit. And we're going to install a couple of things. Let's do zipper non-interactive. And we're going to install BC and kernel source. So we're going to install two things. So it's going to go ahead and get that. And there we go. Okay. So those are installed. That's going to take just a minute. And then we're going to change into the user source Linux directory, and we're going to take a peek at what's in there. So with being in that directory, we're going to create an old config. Basically, it's just going to say grab the current configuration, and we're going to use that from the running kernel. And then we're going to start a make job on creating a kernel, and then come back to the top and look at what is there. So if we do a user source Linux and we do a make old config. All right, so it's looked at the existing running kernel. It's created a config file for us to work. And then we're going to do a make -J3 BZ image, just to put a load on the server. Okay, so this is going to make it do some stuff. Now we're watching over here on the right side. I want you to pay attention to this load value, this first one up here where my cursor is. I'm going to highlight it so you can see it. We're going to watch those numbers right there, and they're changing. They're going up. Now, if you remember, load is how much work is being done over an average of time. One being for a particular number of cores. So each core represents one. So right now it's saying that, hey, we're working those cores pretty hard, and you can see those numbers are consistently going up, and that will continue to do that. Now we're going to wait so that the first value here gets over the value of 1, which we've already got. So we're good. We can go ahead and kill this process. We just wanted to force the system to go up like that to make it work. And then, of course, we're going to clean up after ourselves. So make clean. We'll go ahead and remove all that stuff that we compiled but aren't using. And notice again, come back over here to top and notice that this load value is going down. Okay, and again, that's over the last minute. The average load on the CPUs over the last minute. All right, so top is the go-to tool for most administrators when working with a system and wanting to monitor what's going on. Why? Well, you can see CPU, you can see memory, you can see I/O, you can see swap, you can see all sorts of other things across your system from one tool. And you can get it to update according to your needs. It's very configurable and very easy to read after you get a little bit of experience with it. So top, very good at doing what you needed to do. All right, so that's the first step. Top is one tool for monitoring. Let's look at a couple of other tools that might be of use. If we were to install, let's do a zipper SE for sysstat and see if it's installed. So it is not. So we're going to zipper in sysstat, and it's going to go ahead and install that for us. And we're gonna change some parameters on the server itself. We're gonna reboot this machine, this virtual machine, and we're gonna add a restriction on the amount of memory that it uses. It has, I believe, 2 or 4 gigs of RAM assigned to it. We're gonna cut it down to like 768 and see what that effect is on that machine. All right, so here's what we're gonna do. Let's clear this up. We're going to just reboot this machine and wait for it to come back up, and we're going to break in and assign 768 megs of RAMs here. So we highlight the one we want to edit, we press E, and we scroll down to the Linux line, and we give it a value of mem equal 768M. All right, we've got that added. Then we can do a Control X, which will save it and boot with that value. And we're just going to wait for the machine to come back up. It's going to take just a moment while we do that. Okay, so the machine is back up. We need to see what values it came up with. Make sure that that 768 memory value that we gave it was effective, that I didn't typo or cause a problem there. So we could do, there's a couple of uses or ways to do that. We could do something like a cat on proc command line, and it tells us, oh, yep, sure, there's the value that we had in there. So that's what the Linux value was when the parameters are assigned when the kernel was loaded. We could also do a cat of proc meminfo and look at the memory values, and we can see, if we scroll up here, you can see that the mem total, free values, etc. across there, and that lines up with about what we expected. Okay, so we've got our memory available. So let's work with a couple of tools to just kind of see what's going on here. Let's do a vmstat1 and just see the values that are scrolling by. And now this is going to change. We're going to specifically watch these swap in and swap out values, because we're going to be playing with some memory intensive things, and we're going to see these values climb. So we were looking at load value previously, but now we've restricted memory, and we're going to see what memory does. So when we get in here, we're going to change to that user source Linux directory and do a make -J10 BZ image, and we're going to watch those SI and SO values climb. If you can see, they're already jumping. You can see them just climbing up really fast. And again, we kind of expected that. We limited the amount of memory, and then we said, hey, do something intensive, and so that's what it's doing. So we see that it's going, and we just wanted to demonstrate that you can see what the impact on a machine is, heavy load can be. So we're going to go ahead and kill these things. We're going to kill both of them. All right. So they're not actually doing anything that's important, but with the vmstat tool, we can see how memory is being impacted by a heavy load as well. So let's make clean on this just to clean up our mess. So we've looked at the load on the CPU. We've looked at the load on the memory. Let's take a look at hard drive info and see what we can get there. So let's go and do a zipper in info on a tool called Bonnie. Now, Bonnie is a tool that gives you benchmarks specifically with the file system. And since a hard drive is usually sitting underneath there, this is a good tool for working with that. So let's go ahead and install Bonnie. Zipper in Bonnie. And we'll just get this added in. And then we're going to use tools like LS Block and IO Stat, and then Bonnie itself to take a peek at what's going on. So if let's clear this up and open this up just a little bit more. Give ourselves a little more play area. Let's do an LS Block. And this lists the various block devices that are on this machine. We have 3 what looks like CD-ROM or DVD-ROMs. And then we have some other block devices, hard drives of various types that are in here as well. Now, let's go ahead and over here on one of these, we're going to start an IO stat command to monitor the input-output to these block devices. And we're going to tell it which device we want it to play with. Let's do VDA2 in this case. VDA2 was our root device, if I remember right. If you look over here, you can see that. It is a root device. And if we do a Bonnie-S 1024, this will start generating some stuff to the hard drive. And we can see the impact as these values start to go up. Specifically, we're looking at these await commands. You can see what's going on here as these will change. Let me expand this even more just to give us a full pull across there. Let me do it again. And just watch. You can see these values climb. Await's going up. You see that? And this service TM is going up as well. You can see those being impacted by what Bonnie is doing as it's testing I/O. Okay, so we've got another tool, IO Stat, that we can use to see what's going on with the hard drive. Now, Bonnie is useful just for simulating traffic on your drive, and that's why we installed it. The other item that we haven't looked at is the network. So we've looked at CPU, we've looked at memory, we've looked at hard drive. Let's take a look at network functions and just to take a look at what we can do there for tracking it. Now, all of these things would require a lot more effort, a lot more time in order to become an expert at working with them. This is just the groundwork for knowing that these tools are out there and knowing how the impact on your machines and your environment. You're going to have to spend time looking at them in order to really see what is normal and what is not normal under your circumstances and the loads in your environment. Okay, so let's look at networks now. Let me just go ahead and clear this IO stat. So we're going to install a couple of tools. We're going to do a zipper in of net tools deprecated, just to get the tools that we want here. Because netstat is technically deprecated, but the reason we're installing it is so that you can see that the new tool that is replacing it is called SS, and it gives you a lot of the same functions, even with the same options, but gives you more information actually, and so it's why it's been deprecated, is SS really is moving forward in what it's capable of. So let's start with just a simple comparison. If we do a netstat, and type enter, it spits out a bunch of information. It shows all of your connections, where they're being touched and so forth, what files and so forth. Now, SS, on the other hand, does a similar thing. It just gives a little bit different format for it. So the point here is that SS gives you the same information. It just uses a different format. And in a lot of cases, it gives you more information. Now, if we do a netstat -PATN, it gives you the listening services that are going on there. Let's go and do the SS with the PATN, and notice that we get the same thing pretty much. It's just got a little bit different format for displaying what's going on there. All right, and that was for TCP. Let's look at sockets with additional information. So what we were doing before, but we're just going to put an E on the end. It just gives us a little bit more information on it. And we can do the same thing. You'll notice pretty much the same type of information again being spit out, just with a different format. Let's take a look at UDP. So we do netstat dash PAUN for UDP and SSPAUN. Okay, and again, we can see those differences. And if we wanted additional information, again, you can put the E on there and to see that. Okay, so the point is netstat is deprecated. Some people have complained, well, netstat is a core utility. It's a core function that's been used for many years. Why are you getting rid of it? Well, it's deprecated. It's not completely gone. And secondly, the SS tool actually gives you more information. It's fairly obvious SS has a reason to be used, and we should probably be looking at that going forward. So there you are, working with and monitoring a SUSE Linux box in our environment.